Okay, we're going to use a calculator to help us solve this equation that secant of theta equals -4. Simple enough looking equation. And we're going to give our answer in radian. So that's a clue that we want to be in radian mode for our calculator. All right, so simple looking equation. The first thing I'm going to go ahead and do is rewrite this. We don't have a secant inverse button on our calculator. So let's rewrite this using a reciprocal identity. All right, the reciprocal identity being that secant is 1 over cosine is going to mean the same thing as that secant of theta. And try to work this down where we're trying to solve this equation. 1 over cosine of theta equals -4. So the first thing I would do if I was solving this down is I want to isolate the cosine of theta on one side. So I'm going to initially go ahead and multiply both sides by cosine of theta to get it out of the denominator, right? Multiplying by cosine of theta and dividing by cosine of theta make a 1. So basically eliminates it from that side. This will leave us with 1 equals -4 multiplied by cosine of theta. Again, still trying to get cosine of theta on one side all by itself. So the next thing I'll do is go ahead and divide both sides by that -4 to move it to the other side. All right, it was connected with multiplication, so division should be very nice for us. All right, this gets us the cosine of theta on one side by itself. We need to get theta out from inside of that cosine, so what we'll do is go ahead and apply a cosine inverse or arc cosine to both sides. So we're going to do cosine inverse or arc cosine to -1 over 4, and then arc cosine on this side. The idea being that we'll get theta on the right-hand side by itself. Now, we do want to be a little bit careful. What got returned to me from my calculator was right around 1.823. And let's actually maybe keep a few additional values, maybe round at the very, very end, 82348. All right, so the next thing I want to think about is we just got a value returned to us. Which quadrant is that angle in? Now, I know it's in radian, so it's a little bit tougher to kind of visualize with a decimal and radians. But let's think about which quadrant we're going to get returned a value of 1.8. All right, because we were dealing with cosine. All right, and I'm kind of going back to here where we had cosine equals a negative value. I like the phrase, all students take calculus. All right, this reminds us which quadrant each of our trig functions is positive in. All right, so all of them are positive in the first quadrant. Sine is the only one positive in the second, tangent in the third, and cosine in the fourth. All right, because cosine was equal to a negative number, all right, it cannot be in the first or fourth quadrants. If we were dealing with sine or tangent, we had either of those equal to a negative value. Applying that negative inverse function would return a value in the fourth quadrant. Ours, however, is not in the fourth quadrant. Ours is in the second quadrant. That 1.82 whatever is an angle that's in the second quadrant because cosine is negative in the second quadrant. So if I were to draw that in, just a quick, it is somewhere out here in the second quadrant, that 1.82348 number. What we would like to do is find the reference angle and use that. The reference angle is going to be this angle from our angle that we've drawn in the second quadrant down to the x-axis. Okay, so I'm going to label that as theta bar as our reference angle. So our reference angle is going to be helpful. All right, what we're going to do is we're going to use that to find an additional angle in the third quadrant because cosine is also going to be negative in the third quadrant. All right, so to do that, we've got our quadrant 2 angle, 1.82348. We can also get a quadrant 3 angle by using that reference angle into the third quadrant and placing it there. All right, so that quadrant 3 angle is going to be given by, we're going to start with pi, right, going around halfway around this circle. And then we're going to go an additional reference angle past that. All right, so we need to first calculate our reference angle. That's going to be pi minus 1.82348. So theta bar is going to be right around 1.3181. All right, next, putting that into the third quadrant, we start with our pi and we add theta bar. We add our reference angle. So we're going to add 1.3181. And this works out to be approximately 4.4597. All right, with each of these, what we can do is we can further expand this. All right, so far we've got our angles in the first time around the circle, right, between 0 and 2 pi. But we can expand this by adding whatever the period is for cosine, which is 2 pi, multiplied by k to each one of these. All right, and in both cases, k is an integer. All right, and this represents every single answer we could possibly find out there whenever our secant was equal to -4. So I hope this helps out. I know it was a little rough when I was explaining where to find the reference angle, and then we kind of jumped to how to set it up and use the reference angle, and then back to actually calculating the reference angle. Hopefully it makes sense where this reference angle came from. All right, that reference angle was when we started with halfway around the circle and subtracted away the angle returned based on our calculator. So hope this helps out. Good luck as you're working through these. They're really not that bad, but just take your time and you'll do fine.